The annual growth rate for an investment is found using this function, where R is the annual growth rate, T is the time in years, P, the initial P is the initial investment, and P is the present value. 4 years ago, Anna invested $3,000 at an annual growth rate of 7.8%. What is the present value of Anna's investment? All right, so we've got some values here. We know that the present value, oh no, we don't know the present value. That's what we're looking for. What we have is the initial value, which was $3,000. What we do know is that the time is 4 years, and we know the rate was 7.8%. So we could insolve this to try to see if it would give us the correct value. The insolve might give us the positive answer, might give us the negative answer. You could go to graph. This is real world. We know that we'd not be talking about negative time. We're talking about positive time. So you could be looking at in a positive value here for the present value. You could look for an intersection in the first quadrant and do it that way as well. What I will do though first is I'll do the algebra, and then I'll come back in. So we have 7.8%, which is the same thing as, let me just change this, 0.078 would equal 1/4 natural log of P over 3,000. All right, to start simplifying this, I'm trying to get P solved for, so I'm going to first multiply both sides by 4 here. If I multiply this side by 4, and multiply this side by 4, I'm going to check this value. I believe this will be, well, let me just check it. Why am I going to risk doing the math wrong when I got a calculator right here? So I do 7.8%. I just like typing these in just so I don't make any silly mistakes. Times 4, that is 0.312. So I have 0.312 equals, those go away here. So the natural log of P over 3,000. If you remember, one natural log dividing is the same thing as two natural logs subtracting. So from here, I can add a natural log of 3,000 to both sides. And so I'm going to go type this part in the calculator and see what I get. So I'm going to take that 0.312, and I'm going to add it to the natural log of 3,000, and we get this value, 8.3, I'm going to say 8.32. So 8.32 will equal the natural log of P. And now to get rid of a natural log, remember natural log has a base of E here. This is saying E to this power equals P, so I can rewrite this as E to the 8.32 equals P. Let me make that E look a little better. There we go. So if I come back over here, the better way in the calculator is I'm going to press E, and I'm just going to highlight this value right there, like that, and copy it. This will get a more exact answer. That should be the cost I get, or that's the value of the account after 4 years. So we have here P equals $44,098, and since this is money, we're round to the nearest hundredth, 0.46. This should be my answer here. Now let's check some of those other techniques that I mentioned a second ago. Let's try insolve. Let's see if the insolve would have given us the right answer or if it would have given a different one. I'll go to menu, 3 for algebra, 1 for numerical solve, and I'll type in the values. We started off with that 7.8% was going to equal 1/4 the natural log, so I'm going to do times natural log of P divided by 3,000, and we're looking for P, so we'll do comma P like that, and notice that is the exact same answer. So insolve would have done it the whole way. The other way you could have done it is by that graphing technique. We would have set 7.8% as one equation because it's on the left of the equal sign. And on the right of the equal sign, we would have had the left side of the equation, excuse me, the right side of the equation, which is 1/4 times natural log, and I have to exchange here the p for an x. Let's say x over 3,000, and we would look for the intersection. We already know the intersection is going to come about, x was going to equal around $4,100 about, so I'll say 4,200, hit enter, and now we'll be able to get the intersection here. I go menu, analyze graph, intersection, and as I look at this, there's my intersection. And again, it doesn't give me my value very well here in the graph because how large the number is, but that's the other way, the other techniques of solving this.